Welcome to Miss Smith's Math Tutorials. I'm Miss Smith. In this video we're going to be talking about special right triangles, and the rules that I'm going to show you today are kind of like shortcuts. They're not by any means the only way to solve these problems, and I'll try to point out ways your teachers might instruct you to solve the problems that may be different. But these are the shortest way to solve these problems, in my opinion, and that's why I like them. I'm all about shortcuts. So the first type of special right triangle we're going to talk about is a 30, 60, 90 triangle. So obviously this triangle is a right triangle, right? And I know that because one of the angles is 90 degrees. Okay, the other angle will be 30 and the other angle will be 60. So this is kind of the setup for a 30, 60, 90 triangle. Notice we have our 90 degree little box here. That box means that's 90 degrees. The 60 degrees will be opposite the longer leg. Okay, so when you have a 60 here, that means the one opposite from it. And we've been talking about opposite a lot with SOHCAHTOA. Okay, and that's like if I'm standing here, if I look directly across, that's my opposite. Okay, the side opposite the 30 degrees, that's going to be your shorter leg. Okay, and the side opposite the 90 degrees, that's the hypotenuse. Always. That's always going to be our hypotenuse. Okay, so the rules I've highlighted here in green, okay? These are the two rules you would have to memorize for a 30, 60, 90 triangle. These are the shortcuts, okay? The first shortcut is the hypotenuse equals 2 times the shorter leg. Okay, that's one of the rules. The second rule is the longer leg equals the square root of 3 times the shorter leg. So if we know at least a little bit of information, right, we could try to figure out what the other sides are using very quick shortcuts. So let's start with an example. This one says the shorter leg of a 30, 60, 90 triangle is the square root of 6. Find the length of the other two sides. Okay, so let's lay out what we know. I'm going to draw a diagram because I think everything's always easier if you could see a visual representation. Okay, so let's do some labeling now based on what I know. Now I know that this is a right triangle, right? So that means that this would be my 90 degree angle. I'm going to mark that one with a box. Now I've got to think, because I want this to be an accurate visual representation, which side would be my shortest side? I know this is the longest. That's the hypotenuse because it's opposite the right angle, right? Just like here. But which one would be the shorter? This one or this one? And to me, it clearly looks like this one is the shorter leg. So I'm going to make the angle opposite the shortest leg, I'm going to make that the 30 degrees, the smaller amount. And if that makes this the longest leg, then I want to make the opposite angle from it the 60 degrees. Okay, now let's label what we know. So the shorter leg is square root of 6. So we are calling this the shorter leg, and so I'm going to call it square root of 6. So we need to find this side, and we need to find this side. So a lot of times they won't give you a picture to go on. You're going to have to create your own picture. So that's some guidance to help you do that. Okay, so now my rules come to play. I need to know both the hypotenuse and I need to know the longer side. So let's look at what I've got to work with up here. Hypotenuse equals 2 times the shorter leg. Well, that's good, right? Because I know the shorter leg. So I could easily use this to solve for the hypotenuse. And we'll see how that's done. Or we could use longer leg equals square root of 3 times the shorter leg. Well, again, I know the shorter leg. So this one, I could really start with either rule. Sometimes you can only start with one based on the information given. But here, I could pick either rule to start with. I'm just going to start with the hypotenuse since it's first. Okay? So the way I would write this is the hypotenuse equals, I'm just writing this exactly as I see it written, 2 times the shorter leg. Now, I know the shorter leg is square root of 6. So 2 times square root of 6. Okay, so right here is my answer, the hypotenuse, what I'm looking for. Or you could shorten it and write HYP. I see that a lot. The hypotenuse is 2 times the square root of 6. Now, you can put in your calculator, I could go in and I could do 2 times square root of 6, right? And I'm going to get a decimal, okay? And if your instructions say write a decimal, then you would write 4.9 or whatever you're told to round to, okay? But usually on these type of questions at the level that we're working with, they want a simplified radical. Sometimes they want a decimal, but usually they want a simplified radical. So I would want to leave this in simplified radical form. So I would ask myself, okay, can I break down 6? Can I simplify the radical 6 anymore? Now, if you don't have any idea what I'm talking about, simplified radicals, you definitely need to check out my simplifying radical videos first before you start trying to tackle this stuff, okay? So watch those before. Now, I could try to do a factor tree with 6. The only thing I'd be able to pull out would be 2 and 3, and I wouldn't have a pair of anything, which means 6, square root of 6, is in its most simplified form, okay? Now, in math, we don't really write this 2 times square root of 6, right? We kind of simplify it and we say the hypotenuse, and I'll just put HYP this time, equals 2 times square root of 6. These two say the exact same thing. So obviously this is the more simple, sleek way to write it. Okay, so we'll go ahead and label that 2 times square root of 6. There's my hypotenuse. But I still need to know the longer side, right? So now I'm going to come to that other rule. The longer leg, that's what I'm looking for, so let's write that. Longer leg equals square root of 3 times the shorter leg. And the shorter leg they gave me, that's square root of 6. Now I've got to think back to my radical operations. So you're definitely going to want to check out my video on multiplying radicals, okay? So let's go ahead and simplify this. So the longer leg, here we go, let's write it longer. And sometimes you'll see that, like LL for longer leg. I just write longer leg equals. So remember, we take the number outside the radicals. In this case, it's an understood 1 for each. 1 times 1 is 1, right? And square root of 3 times the square root of 6, well, that is the square root of 18. And then I want to think, can I reduce square root of 18? And let's try it, right? I'll come up here, 18. We'll do our little factor tree. I know 9 and 2, right? And then 2's a dead end, so for 9 I've got 3 and 3. So there's a pair. The 2 is going to stay in jail in the radical. Okay, so the 3 gets to come out. So I know my longer leg, and this time I'll just put L, right, equals 3 times the square root of 2. All right, so I'll note that 3 times the square root of 2. So now I've found the link to all sides. Now, I understand that felt long, right, because I was really explaining each one and teaching it, but once you get the hang of these rules, this is a real shortcut. Now, some teachers may tell you, okay, that the only, or not the only way, but the way they want you to solve it is to use SOHCAHTOA. So if we know one side and at least one angle, we can use SOHCAHTOA to figure out another side. And then once you know those two sides, you can use Pythagorean theorem to figure out the third side, or you could use SOHCAHTOA again to figure out the third side. There's plenty of options, okay? I think arguably, once you get the hang of this, this is the shortest option, but it's totally your preference and based on how your teacher is wanting you to solve it. Let's look at some more examples. So this one says the hypotenuse of a 30, 60, 90 triangle is 10. Find the other sides. Okay, so again, we definitely want to draw a picture, so let's do that. So I'm going to label this corner the right triangle, right? That's the one that's the right angle, so I'll label that with a box. That's my 90. I'm going to label which one would be my shorter side, right? So between this one and this one, I would definitely say this one. And honestly, anytime I'm given the ability to draw a representation, they haven't given me a picture like they have for this last example we're gonna do. Anytime I'm able to draw it, I always make it look like this, right? Because I'm kind of used to how this representation looks with the shortest right here, the longest right here. It's your visual representation. You may draw it a different way. It's completely fine. It's just a visual to help guide us, okay? It's not by any means an accurate, drawn to scale representation of what we're creating. Okay, so if this is my shortest side, right, then the angle opposite will be the 30 degrees, and if this is the longer side, then the angle opposite will be the 60, and this side would be the hypotenuse. Why? Because it's opposite the 90 degrees. That's going to be the longest side. Okay, so what do we know? We know the hypotenuse is 10. So let's label the hypotenuse 10. And I need to be able to find the shorter side and the longer side. So looking back at my two rules that you definitely want to memorize if you're doing special right triangles. One, I could start with this rule, the hypotenuse, which I know is 10. So that would be 10 equals 2 times the shorter leg. Okay, I could definitely start with that one. Or longer leg equals square root of 3 times shorter leg. Well, I don't know the longer leg, and I don't know the shorter leg, so I cannot start with that second rule. I can only start with the one rule I at least know some part of, right? I know the hypotenuse, so I have to start with the first rule. So let's use it. Hypotenuse equals 2 times the shorter leg. Well, the hypotenuse is 10. Right, so we got 10 equals 2 times the shorter leg. And let's just call it, for simplicity's sake, instead of writing shorter leg, which you can totally do, I'll just write x, right? 2 times x. Okay, now in order to get x alone, I know this is 2 times x, so I want to do the opposite. I want to divide, right? 2 divided by 2 we know is 1. And if I do that to one side, of course, I have to do it to the other. So at this point, my x is alone, right? And I've got 10 divided by 2, which I know is 5. So there was my shorter side. Remember I said x I was going to call my shorter side? I know my shorter side is 5. Now to figure out the longer leg, now I can go to the second one. The longer leg equals... So let's write that out. Longer leg, and I can just do L, right, for space. Longer leg equals square root of 3 times the shorter leg, which we called 5. Or we know is 5, I should say. All right, now square root of 3 times 5. This goes back again, kind of like we did over here. Right there, this goes back to radical operations, okay? So square root of 3 times 5, we always multiply the outside coefficient, right, the outside number or letter, with the other outside number or letter, right? So in this case, it's an understood 1 out here. So 1 times 5, we know is 5, right? So longer leg equals 1 times 5 is 5. And we've got square root of 3, and I don't have a radical here to combine with that square root of 3. That's okay. We'll just bring down square root of 3. So these two statements really say the same thing, right? Square root of 3 times 5, 5 times square root of 3. This is just how we like to see it. This is the official way to write it, okay? And I would, of course, want to think, can I simplify this radical at all? If I tried to do a factor tree with 3, the only thing I could pull out would be a 1 and a 3. So that doesn't help me, right? Which tells me square root of 3 is as simplified as it gets. So I now know my longer leg. It's 5 times square root of 3. Okay, let's look at this last example down here. So this one, they didn't give me a written version. They just gave me a picture. And they told me to find A and B. And what's nice is they already labeled my 30, my 60, and my 90. So I know that whatever is across from here, I know B is my shorter leg, okay, because it's across from the 30. And that would make 9 right here my longer leg. Now you may say this side doesn't look longer than this side. It's just a picture, right? It's just a visual representation. It's not drawn to scale by any means. We would want to recognize I've been given the longer leg. So which rule would I want to start with? I need to find the hypotenuse and the shorter leg. Okay, so which rule would I want to start with? Hypotenuse equals 2 times the shorter leg. I would not want to start there because look, I don't know the hypotenuse and I don't know the shorter leg. So there's nothing I could plug in to solve there. I have nowhere to start, right? But this second rule, the longer leg, well, I know that one. It's 9. So the longer leg, 9, equals square root of 3 times the shorter leg. Well, we said the shorter leg would be B, right? Because it's opposite the 30, B. So we're solving for B. So this is B times square root of 3. Now, you could turn this problem into, I could divide this by square root of 3. That would become a situation where we have to rationalize the denominator, which is completely fine. I will say, I know at my school, we only rationalize the denominator for honors level courses, so I'm not going to show that way. It's a perfectly acceptable way to go. So what we can do instead is think to myself, okay, I don't want to divide by square root of 3, but there's another option. When I see this situation, I tell my students, when you see a square root of something times a letter, okay, I can take this whole thing and square it. Okay, now if I do that to one side, I have to be fair and I have to do it to the other, right? So let's think, what is the square of 9? So 9 squared, 9 times 9 is 81, right? So 81 equals. Now, anytime I take the square of a square root, remember how they cancel each other out, right? Those are two inverse operations that I'm doing. They are the inverse of each other. So all I have left is just the 3, just what's left underneath the square root. And then outside of it, so I still have my times, b squared, right? So I just have 3b squared. So that's a way to get rid of that radical without having to rationalize the denominator. Great little trick. This is 3 times b squared, so of course I want to get b squared alone. How do I undo times? I divide. 3 divided by 3 is 1. What I do to one side, I have to do to the other. 81 divided by 3, that's going to be 27. So I've got 27 equals b squared. But now I got to be careful because they don't want to know b squared, they want to know b. So how do I get rid of that little 2? Well, remember that we can take the radical, right? If we take the square root of a square, it's kind of like canceling out that little 2, right? The radical and the 2 go away, but of course I have to do it to both sides. Square root of 27, well, I'm going to need to write that over here, right? 27, and let me break that down. So what are 2? I'm going to simplify it. 2 factors that go into 27, any 2 factors. And I immediately think 9 and 3. 3 is a dead end, 9 is not. I could break 9 down to 3 and 3. Remember, I'm looking for pairs, sets of 2. So there's one pair, that's a 3 that gets to come out. So we got b equals 3 times the square root of the 1 3 that's left over. So I know b now, it's 3 square root of 3. Okay, I just need to figure out what a is. So now I can go back to that original rule, the hypotenuse, in this case a. So I'll just say a equals, or I could write hypotenuse equals, either way, 2. So a equals 2 times the shorter leg. And I know the shorter leg now, it's 3 times square root of 3. Well, this I can solve real quick if I just remember my radical operations. A equals 2 times 3 is 6, square root of 3. Right? Could I break 3 down anymore? Could I simplify it anymore? No, that's its most simplified form. So I know A now is 6 times the square root of 3. The next type of special right triangle we're going to talk about is a 45, 45, 90 triangle. So this one has a completely different way of solving than the 30, 60, 90 triangle. Okay, but this one has its own shortcut. So the way we work a 45, 45, 90 triangle, it would look something like this, right? You've got your 90 degree here. You've got your 45 degrees, 45 degrees. So the other two angles are equal, okay? So it doesn't matter. Notice how on the other one I labeled one the shorter leg and one the longer leg on the first page. Well, here it doesn't matter, right? My two legs will be equal. That's what these little tick marks mean. They mean that these two lengths are congruent. They are the same. Okay, so just like these two are the same, these two are the same. So we just call them leg and leg. They're the exact same length. And then of course the one opposite the right is called the hypotenuse. That's the same from the other video. The hypotenuse equals the square root of 2 times a leg. Doesn't matter which leg, just pick one. Whatever one leg is, so is the other leg. Find the length of a 45, 45, 90 triangle if the hypotenuse is 10. So first, let's just draw this so we can visually see this triangle. Okay, so I'm going to label the one corner 90. I know this is 90 degrees. And I know my other two angles, if it's a 45, 45, 90, they both have to be 45 degrees. So I can go ahead and label those. Now it tells me the hypotenuse is 10. So I'm going to go ahead and label the hypotenuse 10. And I need to know what the legs are, right? Find the length of each leg, and they'll be the same. So let me use this rule. The hypotenuse, right, 10, equals square root of 2 times a leg. Let's just call a leg x. We'll just call it x. Right? Now, again, we're in a situation just like with that last example where I could rationalize the denominator with this. However, I'm going to show you an alternative. I'm going to take this and square it. And of course, if I do that to one side, I have to do it to the other. 10 squared would be 100. Square root of 2 brought to the second power is just 2. Remember, it's whatever is just left underneath the radical. X squared is x squared. Now we can divide by 2. And I get 50 equals x squared. But remember, I don't want to know x squared. I just want to know x, just one leg. So I do need to take the square root of each side. Now, we've got x alone, but I need to think, is 50 the most simplified form of that radical? And it definitely is not. So I want to do a breakdown up here. 50, and I think, what are two factors that go into 50? Any two. I would pick 5 and 10. Right? And then 10, of course, I can break down to 5 and 2. So at this point, I've got a pair of 5s. The 2 has to stay in jail. Okay, so I've got a 5 times a square root of 2 equals x. So if this leg, which I had originally picked as x, is 5 times square root of 2, then so is this leg, right? Because they are even. They are equal to each other. All right, let's look at one more example. Find the hypotenuse of a 45, 45, 90 triangle if the leg is 7. Okay, so let's draw this triangle. All right, we will label this corner 90 degrees. It doesn't matter which side I label first, 45, because they are both 45 degrees. It told me this is a 45, 45, 90. All right, now it tells me a leg is 7. So I'll just label this leg 7. But then I can make the jump that if this leg is 7, so is this leg, because they are equivalent. They are equal to each other. I just need to figure out the hypotenuse. So I'm going to use this formula, and I'm going to say the hypotenuse, and I'll just put HYP, right? The hypotenuse equals 2, square root of 2, times a leg, 7. Right? So square root of 2 times 7, this is when these radical operations come in hand. So 1, they understood 1 out here, times 7 is just 7, right? And then I don't have a radical here to combine with the square root of 2, so it just comes down. 7 times square root of 2. Of course, these two say the exact same thing. This is just the more appropriate way to write it. So we'll just label that 7 times square root of 2. All right, so one thing I want to point out is probably the biggest student error I see after students learn this 45, 45, 90 and the 30, 60, 90 tricks, if you will, shortcuts, is that they want to apply that to every single right triangle that they see. And you can only use 45, 45, 90 or 30, 60, 90 if you are either A, explicitly told it was one of those triangles, so 45, 45, 90, 30, 60, 90, if you were explicitly told it was that type of triangle, or if they've given you a picture where, in this case, at least one angle is labeled 45 and one is a 90, or if it was a 30, 60, 90, as long as one is 90 and they've told you at least one of the angles is 30 or 60. You can never, ever, ever assume a right triangle is a 30, 60, 90 or a 45, 45, 90, okay? Only if you're told. That's the only time you can use these shortcuts, okay? I want to give you guys a little example to try. So for a 30, 60, 90 triangle with a shorter leg measuring 6, find the longer leg and the hypotenuse. Okay, so that's going to be kind of like the very first example that we did together if you want to look back at that one, okay? When you're given the shorter leg and asked to find the other two. So I will post the answer in the video description below. This has been Miss Smith's Math Tutorials.